So we were discussing about this particular question. Since we have total as 25 uh, as the students were surveyed, and it was found at 12. Sorry, it was found at 12 physics, 11 chemistry, 15 math, and the combinations have been given after that. So obviously it is easy to mention here. Better you draw all the three circles and have the intersections together visible, like A, B, C, D, E, F, G till G is there. So obviously all the summation, if you want to go for the complete physics, it will be this much. The complete math, it will be this much. Complete chemistry, it will be like this. So, and we have we can say other things are given. So easily we can solve from here. What are the total number of students? Okay. With the help of this way, we can easily finalize. So if I just this question, this is part of important. Just, okay, so I'll go further from here. That is, whenever we have all these things, we can easily find all the parts here very easily. So, okay, this will be the end number of students who offered none of the three subjects. None of the three subjects. So obviously we have total we are having a student who offered at least one of the given. At least one of the given is 23, so two hasn't taken part in any of them. So easily we can finalize this. As a summary of key facts, let us go further with this. That is, a well-defined collection will be set, and object in the set is element, members, or points. Usually we denote set by capital letters. The set is usually described in tabular form or set builder form. In tabulation method, we make a list of objects and put them in braces. We will see it braces, not brackets, braces. In set builder form, so brackets are often used to include additional information or clarification within text, and braces are usually used. They used to group multiple items or sets together. So braces we will call it the set builder. In the case of tabulation or method, in the case of tabulation form, generally what we do, we keep We make a list. So list, we just keep it there. In the case of set builder, we write as X such that X satisfies probability P, okay, which mean the set of all those X such that X satisfies properties P. So we can say like that for that because we have only two varieties of set notation. Just quickly go there. So set notation, roster form or tabulation method is there, and set builder. There are only two ways to analyze this particular part. Okay, set has having no elements at all is called a null set or void set, and it is denoted by phi. Now don't get confused whenever we say phi. Phi is a set representation and not an element. So it is sufficient to just denote only phi, which is having no elements. If we denote in a with the braces, it can be an element of that if it is there in a particular set, but we don't denote like that. Okay. So even so for the subset case, we have to be very clear on this because subset case does should have set form. If you say set A is a subset of B or is a proper subset, in that case both will be in set form, not in some other form. Obviously, phi is in the set form by default. Set having a single element or a singleton set. Infinite number of sets can be there, finite number of sets can be there. NA, when we write, it is called number of elements. Two sets have exactly the same elements are known as equal sets. So whenever there are two sets having same elements are exactly same. Ordering is not important. We will say there's an equal set. If uh, it is same means the element should be same. Counting obviously will be same here. So equal set will be equivalent, but equivalent set will not be equal because equivalent can be number will be same, but element can be different. So that is the case. Uh, a set A is called subset of a set B if every element of A is in B and we write A belongs to, or sorry, A is subset of B, a set a set A is a subset of a set B. Set A is a subset of a set B if every element of A is in B and we write A is a subset of B. A is subset of B and A is not equal to B, then A is a proper subset of B and we write A in a proper subset symbol. We use the total number of subsets of A containing n elements is 2 to the power of n. So number of subsets for any set A. Collection of all subset of A is called the power set of A to be denoted by PA. Let A and B be real numbers so that so collection of all subsets of a set is called power set. Whatever number of sets we can have from there. And counting is to the power of n every time and denotes the number of elements of the set A. Close interval open, half, right half open, left half open. We can denote like that, and union we are very clear. Union means either A or B. Interaction, it will be A and B. Subtraction, A minus B will be not, X will not belong to B. And here it will, B minus A will not belong to A. Symmetric difference, A minus B union. The symmetric difference, this A symmetric B will be written as A minus B union B minus A. So A is a subset of the universal set U, then the complement of A denoted by a dash, a to the power of c, or a cap, or u minus a is defined as a dash or a complement. X says that x belongs to u and x does not belongs to a. So these are laws we have already seen it earlier. Union, intersection part we have already seen. Okay. So A union A is A then and in them potent law says that A union A will be the same, intersection will be the same, identity law will be A union phi will be A intersection the universal set will be A only again, union B union A intersection. So it is commutative law. This is associative law wherever we say that union B, union C, A union B union C, and A intersection B intersection C, and A intersection B intersection B. So just practice by changing here. Distributive again the same thing, but distributive we should be very clear. A union B intersection C when we're writing, so we'll just convert it. A union B intersection B union C separately. In the case of A intersection B union C, so it will be A intersection B union separately. We'll write and A intersection C, A union B. So these are the distributive other ones. Are De Morgan's law is A union B. Complement will be A complement, intersection B complement, and even A intersection B complement will be just opposite of that. That is A complement union B complement. De Morgan's law. And now the last one, that is a very important part. That is of two sets union of number of elements of A union B will be equal to number of elements of A. Number of elements of B minus number of elements of A intersection B. A number of elements of A minus B. And number of elements of A intersection B will be NA, number of elements of A intersection B and number of elements of B minus A will be NB, and A symmetric B, number of elements of A symmetric B will be number of elements of A minus B plus number of elements of B minus A. So in the case of symmetric, we should be very clear that whenever we write this symmetric part, so generally the A symmetric B is denoted as A minus B union of B minus A, and here number of elements of A symmetric B will be number of elements of A minus B plus number of elements of B minus A. Whenever we have three sets we are having, in that case we will say that number of elements of A union B union C will be equal to number of elements of A, B, C separately minus, first we'll do plus here, number of elements of A, number of elements of B, number of elements of C plus number of elements of A intersection B intersection C. Now negative number of elements of A intersection B minus negative number of elements of B intersection C, then number of elements of A intersection C, all are in subtraction part. Okay. So that is the over part for sets we are over right now.